Hi and welcome to a new video here on my channel. Finally, also again a video in English. And today we're taking a look together at the Z390 AORUS Master from Gigabyte. And I want to test this board because I saw a video from Hardware Unboxed where he was comparing different Z390 boards under load, and he checked the VRM temperature in different situations, like on an open test bench, in a case, under load, in idle and all that. So maybe go to the link in the description first, check out his video. It's extremely recommended. And in today's video, we will also take a look at this board. We will basically do the same comparison as what he did. So we will also take a look at VRM temperatures. We will take a closer look at some of the features of the board. And I will compare this board to the Maximus 11 Extreme and also to the MSI Godlike, because I think those boards are kind of in the same region for the enthusiast market. So I'm very curious how good the cooling solution of this board really is, because if you just take a look at it, you can already see that it has those thin heat sinks, the finned heat sinks, and I think they should be very good for cooling. Before I will test this board and before I will disassemble it, we will quickly go over some of the features of this board, which I found when I did the first and basic optical inspection. So especially here in front, we have two EPS connectors for CPU voltage supply. What I find really interesting is the fact that we have shields around them. I think it's the first time that I saw that there are shields around the EPS connector. I'm not sure if there is any technical reason why you should do that, but it's something I have not seen before, or maybe I missed it in the past. If there was a board like this before, please feel free to comment it down below so I can also educate myself further. Talking about shielding, we also have metal shielding around the memory slots, and when those first made it to the market, I always thought this is kind of marketing bullshit, like why would you need enforced memory slots? And then I actually was testing a very cheap mainboard, and if you take a look at a DDR4 stick, you will see that the middle part is a little bit higher than the outer part. This is mainly so if you apply the pressure to the socket, you don't have to apply it to all of the socket contacts at once. You divide it by like 50-50. But even if you do that, if you press it into the slot, the way I do it, I just smash it into the slot, then I sometimes see that the mainboard is bending quite heavily at this position. And if you have those metal shieldings around them, they actually don't bend that much. So in this regard, I have to give them that the metal shielding should actually help. A very small feature, but something I really appreciate, is the fact that we have a socketed BIOS chip. We actually have two BIOS chips on here, as usual on Gigabyte boards, but one of them is in a socket, so we can take it out in case something goes wrong, or you can buy additional ones, you can flash them yourself. So for example, you can have 3 or 4 different BIOS versions and just put them in the socket and do easier and faster testing this way. That's something I used to do in the past when I was doing extreme overclocking. Talking about extreme overclocking, we also have voltage measurement points, which is something, in my opinion, that's absolutely necessary for a high-end board, because you cannot always trust software, especially doing reviews. It's really important to have accurate voltage reading points. So we have them on top here near the DIMM slots, and they're also very easy accessible in this position, especially doing extreme overclocking. Another visual feature I really appreciate is the fact that we have metal shieldings or coolers on all of the M.2 slots, which is something that's not really necessary from a cooling point of view, but visually it's really nice because, I mean, of course, a 960 from Samsung or 970, they are kind of nice to look at because they're just black, but then there are also the uglier SSDs on the market that are just green, and if we already have those coolers on here that already fit the design of the board, I think it's a nice feature to have. Let's go over the VRM design quickly. So we have a 12-phase CPU design. The controller is an international rectifier IR35201, which is a solid controller. It only has 6 outputs though, which means that the CPU phases are doubled to 12 phases, which is still good because we then have a massive amount of phases where the load is spread on and also the heat is spread across a bigger surface area on the mainboard, which surely helps VRM temperatures. One more feature that is extremely important and something you should always look for is the fact that we have 2 copper layers on this board with a thickness of 35 micrometers. So that means we have more copper inside the PCB, which results in a lower resistance of the copper layers. And because if we have a lower resistance, the copper layers are not heating up as much. And also if we have more copper inside the PCB, that's something that's quite logical, I think, is that it is easier to spread the heat across the PCB itself, because a lot of the heat from the VRM components are usually removed or spread directly over the PCB and not just the heatsink. So that's something That's really important and will surely help the VRM temperatures. One more thing that I find really interesting is the backplate. We have seen such backplates on many boards previously, but what I saw is that we have actually thermal pads between the PCB and the backplate. So that means that the backplate will also do its part cooling wise, and the question is, how much does a backplate like this actually help? So in this video I will later remove the backplate and double check how much the backplate actually helps, because on other boards I have seen on the market the backplate is typically just for mechanical support. So if you hold it like this, it cannot bend because the backplate will give it a lot of stability, and in this case the backplate also does a thermal part. So we will take a look at how much the backplate actually helps, and then we will also do testing and comparison of the VRM temperatures. So I spent my full Saturday testing the AORUS Master, comparing it with the Maximus 11 Extreme and also with the MSI Godlike in terms of VRM temperatures, and I have to say I'm quite impressed, especially when it comes to the point that this board is quite a lot cheaper. So the first test, or the first thing I was interested in, is how much does this backplate actually help. So I performed a Prime 95 run where the CPU was pulling 200 watt load from the EPS connector, and the first test was just on an open test bench, so no airflow, just the CPU water cooled. So it really is just about the heatsink design, there is no airflow involved. In the first test, after 30 minutes, the VRM temperatures hit a maximum of 75 degrees Celsius on the AORUS Master. This is stock with backplate. Then I removed the backplate and the temperature increased to 82 degrees Celsius. So 7 degrees just by having the backplate attached with some thermal pads. And I think that's quite impressive considering that it's just a metal shield, and I've seen it on some other mainboards before where it was not connected with thermal pads to the PCB. So I think I can just recommend this to mainboard manufacturers, that you should do this in future, especially on the higher priced mainboards. I think shouldn't add that much cost to the product, but seems to help quite a lot. So let's compare the temperatures to the Maximus 11 Extreme and also to the MSI Godlike. With no airflow, 200 watt pulling from the EPS connector after 30 minutes, the AORUS Master, as I said before, reached 75 degrees Celsius under load, the MSI Godlike 85 degrees Celsius, and the Maximum 11 Extreme 84 degrees Celsius. So all the temperatures are absolutely fine on all boards. It's not a problem. It's just very interesting that AORUS Master is cheaper and performs up to 10 degrees better. Now adding airflow. So I mounted those mainboards in an O11 dynamic with a 240 AIO, which was then cooling the CPU and also pulling some air across the VRM. This helped to drop the VRM temperatures, so on the AORUS Master it dropped to 66 degrees Celsius under load, on the MSI Godlike 79 degrees Celsius under load, and the Asus Maximus 11 69 degrees Celsius under load. So in general I can say all the mainboards are fine when it comes to VRM temperatures, but as I said before, it's quite impressive that the AORUS Master is so much cheaper and when it comes to the VRM temperature so much better. I was also quite impressed that the influence of the backplate is that much. I didn't expect 7 degrees Celsius. I was probably thinking about 3 or 4 degrees Celsius. So that's quite a lot. I didn't expect that. Let me know what you think about this board in the comments below. Let me know if you maybe already upgraded to Z390, which board you have, what kind of VRM temperatures you experienced. So much for this video. See you soon.